Hello everyone, this is Bradley. I don't have much time, so I will try to be as fast as possible. Earlier, I posted a shot that I was making talking about flipping book pages. People asked for a tutorial, and I referred him to my below the calendar pages tutorial. However, this is actually not right. Although both animation share lots of their techniques, there are some very critical differences between these two animations. Basically, my flipping book animation is not driven by fourth. In fact, I haven't used the fourth in that animation at all, and this new technique will largely improve the below the calendar page animation as well. Before we actually start, I want to mention that I have made series tutorials talking about fourth, such as the way to visualize that, the meaning of its parameters. These are basic knowledges, but they are critically important, especially when the parameters cause the problems in below the calendar pages animation. So I hope you will find a time to check them out if you haven't. So let's just start with the new technique. When talking about flipping pages, we need a book, but I don't want to talk about a book. It's basically just to model a book, and then you use armature to parent two kind of pages, and then by controlling the armature, we're going to open a book. I suppose there are tutorials talking about how to open a book and how to use the armature parents to a human model or whatever other stuff. Basically, the idea is the same, but the pages are separated. So we are going to make a pages. So I don't care how do you actually model these pages, but one way I'm going to do is just a loop cut in the middle. I'm just delete the other side of faces. What I need to ensure by this modeling is the origin is actually on the one side of the edges, and the rest I don't really care. Okay. Another thing I actually would like to make sure is because is that so firstly let's add a simple transform. So because I want to bend our pages, so if I turn this thing to bend, and you will find that nothing will actually work unless we shift it to Z. There are several reasons to that. One reason is that we don't have enough subdivision surfaces, so I'm going to add several loop cuts. Kind of appropriate amount will be just enough. But it's still not working. The other reason is sometimes the simple deform modifier is so weird that you just have to rotate Y for -90 degrees. And then now it's started to work. So this is kind of very weird. I don't really know why it happens, but anyway, just have to get used to that. And then I'm going to add the subdivision surfaces. If you want your pages to become sharper, so you can definitely just add several lines. So now it becomes sharper on its edges. So now we get the pages, and you shade smooth that. We have a kind of nice one, which is not good when it's not long enough. So I don't know what the shape pages should look like, but it should not look like a square. But who cares? It depends on the books, right? So and we'll just apply the scales. So now we have a nice pages. And if you're doing a single pages, definitely you can do this kind of keyframes. However, if you're doing multiple pages, you want a procedural result, then I think animation node is the way that you should go. So let's go to animation node, and the first thing that I wish to do is to instance this object. I'm going to use Alt-R to clean the rotation, and then call up a node which is called object instancer. I'm going to increase the count, maybe 35, well, whatever, and select our planes and copy full object to ensure all the modifier has been copied to our children object. I'm going to disable the most initial collection so that I don't see that anymore. Next thing I want to do is to use the object transform output, turn on these rotations, and now I can use the node to control the transform data or the rotation data of all my children objects. Okay, this is one part of that. But now these pages are sharing the same rotation data. That's why they still looks like the same pages. There are multiple ways to give kind of offsets. Firstly, I want to show you if I'm going to combine ruler, and then I wish to use degree because it's kind of more easy to type 360 or some other things. And then I'm going to use the float range. Yeah, float range should be a kind of nice thing. And then I'm going to put the objects into the amount, so that if I have 35 objects, then I'm generating 35 numbers. And finally, if I put this list into the combined ruler, the Y, then I'm having a kind of offset of all these pages. You can change this step number so that you get kind of more of an idea about how this actually looks like. So basically you're controlling the offset. And if you want, you can actually take a float math and let's change the type into add. You can use this additional add number to actually flip these all the pages together. Okay, so this is kind of idea about a basic idea about how you can flip the pages, or kind of offset the rotation of all these kind of pages and try to rotate them. But the one important thing that we need to realize is how to actually animate this stuff sequentially. What did I mean is that if you're thinking about a real animation about flipping pages, it should start with everything flat. So it should start with everything flat, that without any offsets, and then the first page starts to flap, and then we start to have a kind of offset. And then at the end, then we have every offset disappeared again. So this should be what real animation looks like. But this is certainly not what we're working with at this moment. So it's not only to delay the value, but also delay the time of action. So as I mentioned about actions, you probably think if I get Shift A, goes to menu, there is actually a group of nodes which is called action. You probably think this is what we are going to do. At some cases, this is true. It's correct. We may potentially use this action from objects and delay action. These are actually two nodes that you wish to use. But I'm not going to use these two nodes at this point. The reason is because for action, you only have these many nodes. You have action from objects, chain actions. These are everything that you have. There is nothing more than that. So there's not even an option to decompose the action. So what's action? You don't actually know what's action. Yes, I can tell you the action is basically the keyframe data of all this transformation. But the issue is you cannot extract anything from this action. Action, it just looks like action. The red dots will be kept red dots throughout the entire course. It's not like we have a transform data which is composed from the location, rotation, scale. You cannot see the data inside the action, but you can see the data inside the transform. Did you get a kind of idea? So if you're working with the rotation only, then it's fine to use action. But the issue is we are not only going to use the location only, but in the future we're also going to work with this simple transform so that we can make it our animation more kind of realistic. And this is the issue that we're facing with. And that's why I'm not going to use action, but use kind of a similar technique that we're still going to delay the action or values. So instead of using the delay action node, I'm going to use a node which is called a delay time. And to make this delay time work, we need two additional nodes. One is we need an actual time information, and the other node is which is called animator float. If I put the time into time, so I can select this node, goes to view and goes to button, and we see a result. So let's first click this delay to 0, because I want to show you how this animated float is actually working. So now if I take this end to maybe 200, put the result into this float math. So we start at frame 0. You can see its output is 10. Oh wait, why its output is 10? Okay, because it should actually start from frame 0, but we start as the frame 1. Okay, and then after these 20 frames, it goes to the value of 200. And in 21, it no longer adds more values. It just stops at 20, as it has been said. The duration of this entire animation is 20 frames. If we add a delay time, for example, like we add kind of 40, then we has no result at all. You can see just in the first 20 frames, we do not have any animation, and we didn't get animation until we actually hit 41, and it will last for 20 frames. And in 61, then there's no more animation. So this is how this series of nodes is looking like. And by using this delay time, so assume if we offset if we delay different if different animation, if different pages has a different time, a number of delay, then there will be a sequential effect that the first will start to animate, and the second will animate later, third will animate even later, and a kind of more sequential event instead of a straightforward one. And how can we actually delay? How can we actually get an offset in such kind of delay? The method is basically what I told you earlier. You put this list into the delay. However, it will give you a node which is called a getListElement. I've discussed in the tutorial about the loop node. What does this means, and the issues, and so on and so forth. And in this particular case, what I can just say is we need to use a loop, and what I can say is that this sequential node is not working the way that we wish, and we have to use a function which is called a loop. And to do that, it's kind of very simple. In object instancer, I'm going to use a hit W, and it goes to right to loop through objects. So now I'm creating a subprogram, and in this iterator, I'm going to create a float list. Okay, and then I'm going to put this list into the float range. So now we have a subprogram, and I'm going to use this subprogram to replace the original linkage. So let's clean up the linkage previously. I'm going to put the object into object, and then I'm going to put this float into the delay. And I'm going to delete this original float math. And we can change all these kind of values and put the results into the Y, and put the Euler's back to rotations. So I think now we're finishing all this kind of setup. So although I have spent lots of time discussing the theory and the concepts and many other things, but in fact we didn't actually really use a lot of nodes. It's just this many, and we are actually close to the end of this tutorial. The next thing we need to do is just to use a map range. Actually, you don't necessarily use map range, but I would suggest you to use map range in this case, and you will know why. You can change the value from this float, but you can also use the map range to change all this float. I'm just going to type the -90 to 90, so that this is the start and end point. So, and then let's just get a quick look, and we see this animation. And this animation will just goes to the end. For example, if I goes to 300, and you finally finish with the flat thing. And this is because everything has been delayed. This is kind of sequential effect. The first pages flipped itself earlier than the others, second earlier than the rest, third earlier than the fourth earlier than fifth, sequential effect, as we have discussed earlier. And what I want you to realize is you can change this duration so that you can decide the the amount of time, the smoothness of all these kind of movements. So you can keep that as 20 or you can increase. You can also change the delayed interval. If this is smaller, then the interval is smaller. Pages are closer to each other, you can increase so that it's just more spread it out or other things. Yeah, these are kind of things that you can play with. Another thing is if I go to frame 1, you can see it's not flat. The reason is because everything is starting from 0, but you can make everything start at 1. This is also a delay. So if you delay 20 frames, then in our first 20 frames, we won't have animation until the 20th frame. So now we have started to have a flipping pages. So these are kind of things that you can play around just to get a kind of idea with all these kind of parameter. What does it mean? So I'm going to take the everything one, step size 3. So kind of nice flipping book animation. And that's why this method is better than FOV, because firstly, if you want to trigger a FOV, it's based on the location, but all our pages are actually have the same location. So if you trigger one, you trigger the others at the same time. Secondly, is FOV can barely control the duration of animation, but using this new method, we can actually control the duration of this method so that animation can potentially looks more smoothly and so on. So last thing that I wish to do before we actually close up is to make this flipping book animation more kind of realistic by controlling its simple deform. The reason we're actually making a simple deform at the most beginning is because when we actually when we start with this animation, everything should look flat. But when I'm flipping the books, it should curve towards the original side, and when it goes over the midline, it should curve towards the target side until it goes to flat again. So what it means is it starts from 0 and it goes to 90, negative 90, and goes through zeros, goes to positive 90, and then finally go back to 0. So this is how this simple deform value should look like. And you see this is a very complicated process of this animation, and especially considering the fact that this animated float, or this actually entire animated series. This entire animated series, whether it's matrix, vector, float, color, Euler, quaternion, blah 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 blah, they are all kind of aimed at a kind of simple action. You have a start and the end, and that should be it. So how can we actually make this animated float value becomes more complicated? And here tends to be the moment that we need to consider these interpolate options. You can interpolate here, but you can also interpolate there. The reason I'm using the map range is because I want to use the same animation data, because both the rotation and the simple deform should occur at the same time. They should synchronize each other. So I'm using one value, but I want to get a kind of two different results. And that's why I'm using the same animated float, but the two map range node to get a different process done. So let's firstly deal with the issue with this map range so that we can get a kind of correct values out from this animated float. We are going to use this interpolate function, and this interpolate really looks like this. So if we go to a node which is curve interpolation, and this is how this node should usually look like. The default is linear, and this is the linear version. What it does is, you probably don't need me to explain to you, but I'm going to explain this anyway. So x-axis is the input, y-axis is the output. So because our input from 0 to 1, so at this kind of 1/4, which is 0.25. So if I put these values upwards, then it means it's more closer to the output maximum. So if I put that to the top, then it means at 0.2 originally I will only hit 90s when it's when it hits 1. The value hits 1, which is at the end of animation. But since I remapped this entire thing with this interpolation, then at 0.25 I'm already hitting this 90 point, the maximum, which is 90. So this is kind of idea. So by using this interpolation, we can definitely screw this entire interpolation so that it make the animation kind of more wavy, crazy, dumb, whatever you call. So this is kind of idea. And here we need 5 points from 0 something to 0 something to 0. So we need 5 points. So now we have 5 points total, which is good. And I'm going to change all this kind of value. Before we change the value, we want to define what's actually the output minimum and the maximum. I don't actually have an answer. So let's just type whatever number, like -45 and maximum 45. Should be nice. So I want the value to start with 0. So 0 is a between number between this, a number exactly between this -45 to 45. So I'm just putting this y to 0.5. Okay. Then for this, the second point, I'm going to hit a negative maximum. So just x 0.25, y should be -1. Y should be negative. Actually, the minimum is negative. Okay. And then the middle point 0.5, 0.5. The maximum 1, 0.75 in x. And finally, everything goes back to the midline. So now we have kind of a curve, but I want them to be kind of more linear. This is my own perception. You don't necessarily listen to me. But if you would like to change the handle, so you just select all these kind of points, and then you can change the vector handle so that they become straight. Okay. So this part is done. Then we just we cannot really confirm with the viewer because the viewer in a loop usually looks kind of very weird. So we try to look at how it actually affects our animation instead. So how can we actually link all this value to this transform the simple deform? It's something essentially very simple. You just take the object attribute output, put the object inside, and if you mouse hang over on this angle, just right click and you get a copy or data path. Then you just get a data path. Finally, put this value into value, and immediately you see something very, very weird happens. What's actually going on? So if you select this object, you realize the deform actually goes to 560 degree, and you don't know what's actually happening. So we need to do a radian to degree. We need a 2 degree to radian. Yeah, I don't know why it actually causes issues, but this is kind of idea. And as soon as we do that, it's finished. This is already nice, and you can definitely change the value. In terms of material, I don't want to dig too deep into material, because if I were to talk about the material, there will not be anything new from this from the previous below the calendar page tutorial. So if you would like to know how to actually assign different pages with different picture material or something like that, you probably would like to watch the previous tutorial. But this is basically all about it, and this is not many notes, even if I spend a lot of time discussing all this kind of theory and whatever stuff. But I think this is kind of very simple setup, but I hope you to actually understand the powerfulness of this animated float in these particular settings instead of using various type of fourth. We do have various type of fourth, but barely they are useful in this particular case. Okay, so this is all about it. I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.